we're about to start unit circle trigonometry, but we never really leave right triangle trigonometry behind. In fact, unit circle trigonometry is building upon right triangle trigonometry. So this is from right triangle trigonometry. Clearly, alpha has to be an acute angle, and we will prove that for such an angle, the sum of sine alpha and cosine alpha is greater than 1. Using our usual standard notation, sine alpha would be from this picture A over C. Cosine alpha would be B over C. And now we're going to do something interesting. We're going to take this triangle and we're going to replace it with another triangle that's similar to this, but has a hypotenuse 1. As it turns out, we really, really like to divide by 1. If you have a ratio where, or if you have a fraction that has, if you have a fraction and the denominator is 1, then the fraction's value is the same as the numerator's value. And that is often very advantageous for us. So to scale this down to a triangle with hypotenuse 1, clearly we have to divide C by C. That means we're going to divide all 3 sides by C. So the hypotenuse becomes 1. The side that used to be A is now A over C. And the side that used to be B is now B over C. And so there are lots of advantages of a triangle with hypotenuse 1. There are lots of advantages of a right triangle with hypotenuse 1. For example, the sides become the trigonometric functions. If we look at this triangle and we apply and we state the basic trigonometric statements, from this picture, sine alpha is A over C over 1, or A over C. So it's basically this side is sine alpha, and similarly, this side is cosine alpha. We can read it. A over C is sine alpha, and B over C is cosine alpha. And if that is so, we just apply the triangle inequality, which states that any 2 sides when added must be more than the third side. So we're gonna have immediately that sine alpha plus cosine alpha is greater than 1, which is what we wanted to prove. Done. But really, this problem is here because this is just one of the many reasons why we prefer to deal with right triangles with hypotenuse 1. You will see the unit circle, the word unit is just a fancy word for 1. And so we're going to deal with a lot of triangles with hypotenuse 1. So I kind of want to revisit all the triangles that we have seen and see what happens when we scale them down to hypotenuse of 1. I think we just dealt with this. If we divide everything by C, A over C or sine alpha would become of the short side opposite alpha. B over C, which is also cosine alpha, would become of the longer side, and this would be 1. There is also an example we can do. The cutest little right triangle with nice sides is 3, 4, 5. So sine alpha from this triangle is 3 over 5. Cosine alpha is 4 over 5. We divide all 3 sides by 5. The hypotenuse becomes 1. The side that used to be 3 is now 3 over 5, which is sine alpha. And the side that used to be 4 is now 4 over 5, which is cosine alpha. Okay, so the most important triangle that you're going to be dealing with is the famous 30, 60, 90 triangle. If you really understand this triangle, I promise you will have to memorize not one thing from the unit circle. There is no reason to memorize, learn little memo techniques or there is no. The unit circle, you can just read it if you understand this triangle. Now, here is the 30-degree angle, here is the 60-degree angle. And the way we created this triangle is we just chopped off a regular triangle in a half, right? And so that, for that reason, this is clearly 1, this is clearly 2, and then the Pythagorean theorem gave us this missing third side being square root of 3. Now, what happens when we scale it down? Well, we want the hypotenuse to be 1, it's 2 now, so we divide by 2. This is going to be a triangle that we're going to see over and over and over during this trigonometry course. And you don't really have to memorize who is who if you just understand that the side opposite 30 degrees is very much visibly shorter than the side opposite the 60-degree angle. If you just look at these function values 1/2 and square root of 3 over 2 as decimals, we will find, I don't have to tell you that 1/2 is 0.5, right? From a teacher's point of view, that's 50%. That's a weak F as an example. On the other hand, if we enter square root of 3 over 2, I managed to do that. That's almost an A as an exam. It's a much larger volume. This is 0.5, and this is nearly 0.9. And that's what you got to remember, because it doesn't matter how it appears. If you have a triangle which has a right angle and say a 60-degree angle somewhere, or a 30-degree angle somewhere, and the hypotenuse is 1, then it is not just similar to this one, but it's congruent, it's identical to that. And that means that the side that's visibly shorter than all the other two is half, and not a hypotenuse, but visibly longer side than half is square root of 3 over 2. That's all that you're going to have to know to understand and use the unit circle correctly. No memorization whatsoever. There's one more triangle, and that has to do with the 45 degree, right? That's basically, we took a square and we chopped it in a half by a diagonal. So if this is the original, we want to scale down to a similar triangle with hypotenuse 1. That means we're going to need to divide everything by square root of 2. So the shorter sides become 1 over square root of 2. And the hypotenuse is 1. That's it. So you're gonna be dealing with these triangles in unit circle trigonometry. Know them well. And as I promised, there will be nothing, absolutely nothing to memorize. Thank you for watching.